Hi everyone, I wanted to go over yet another logarithmic property problem from section 4.4 with you. So what we have right here is actually number 43 from your text, located on page 261. So to begin with this problem, as you can see, you have two different logs in here. So what I'm going to go ahead and do is I'm going to use my log properties to help write this as one log. And what I am noticing right away is that I do have a minus sign that's in between them. So this tells me that I can change this into the log base 6 of x squared all over x plus 1 is equal to 1. And what I want to note here is I basically use my log properties to help me pull this in as tightly as I can before I can actually start doing some work to help me solve this. So the next thing that I'm going to do is I'm going to translate this. I'm kind of at a stopping point with the logarithm, so I need to translate this from a log expression to an exponential expression. So from class, if you recall, we're going to use our swoop method here. So what this is going to tell me is I'm going to have 6 raised to the first power is equal to x squared all over x plus 1. So we can continue to clean this up. This essentially just becomes 6 because 6 to the first power is just 6. And then the right-hand side is going to remain unchanged. Now I'm going to go ahead and basically get everything on the same playing field. So I'm going to multiply both sides by an x plus 1 to clear that denominator out. And on the next line, what I'm going to do is I'm going to go ahead and already distribute this out. So I'm going to have 6x plus 6 is equal to x squared. So hopefully you're kind of seeing something take shape here. And if you don't, this will hopefully kind of put everything into perspective. So now what I'm going to have is 0 is equal to x squared minus 6x minus 6. So my whole strategy in this case of moving, or quote-unquote moving, or basically subtracting the 6x and the 6 from both sides of this equation is so that I have a clearly visible quadratic equation here. And with a quadratic equation, this permits me to use my quadratic formula. And as I write it out, see if you can follow along and make sure that you do remember it correctly. Okay, so what this allows me to do then is I'm going to drop these items in. So I'm going to have a negative 6 plus or minus the square root of negative 6 squared. Notice that I put that negative 6 inside a parentheses. Minus 4 times 1 times negative 6 all over 2 times 1. So my answers are going to be in here. And what I need to be aware of is that just because I'm going to get 2 answers does not mean that both will be answers to my original problem. Remember that if I plug in any of my answers back into my original equation, if I have a logarithm with a negative number inside of it, it's automatically not possible because it's outside of the domain that logarithms have. So when before we end the video, we will double check to make sure that both of these are okay. But before that, let's go ahead and clean up what we have in this representation. So a negative 6 is really just a 6 plus or minus the square root of negative 6 squared is 36. Negative 4 times positive 1 times negative 6 gives me positive 24 all over 2. As I continue to work on this, this is going to give me 36 plus 24, so 6 plus or minus the square root of 60 all over 2. And at this point, I'm going to hop into my calculator and do some decimal approximations. So the 6 plus square root 60 divided by 2 is going to give me about, let's see, 6.873 if I round to the thousandths place. 6 minus the square root of 60 divided by 2 is going to give me about a negative 873. So if you recall, and if you don't, or if you don't have your book next to you, the original equation that we had started off with was the log base 6 of x squared minus the log base 6 of x plus 1 is equal to 1. So what I want to be aware of is that both of my answers here, and don't forget that little negative, I forgot to include that there, both of these could potentially be answers. So if I check, say, this one, if I do the log base 6 of 6.873 minus the log base 6 of 6.873 plus 1 is equal to 1. What I want you to note is I don't have to actually go through the full check. I just need to make sure that the logs inside are going to remain positive. Okay, so as you can see here, this is going to remain positive because, oops, it will be squared, and it's already positive to begin with. And also here, 6.873 plus 1 will also help it to remain positive. So odds are, in this case, this answer is good, so I'm going to keep it. So the next one, let's go ahead and check. So if we have the log base 6 of a negative 0.873, which will be squared, minus the log base 6 of negative 0.873 plus 1 is equal to 1. Let's double check this. So notice that, yes, there is a negative inside of this log, but it is being squared. So that's going to make it positive, so we're okay here. And then you have a negative 0.873 plus 1. Well, since the 1 is kind of the larger number and is also positive, we know that the sum here is going to stay positive as well. So this one actually checks out as well. So in this case, when you are presenting your answers, you want to include both of these as your solutions. I hope that this was helpful. If you do have any other questions, please let me know.